Hello teacher and everyone. Today our team is excited to present our final project called VibeFlow. VibeFlow is a mobile app designed to help musicians learn and practice songs much easier. It brings together music playback, fast song search, lyric chop, and lesson material into one simple app. We build the front end with Flutter and the back end with Nest.js. And here is our team: Nodavin, Vidarat, Prajna, and me, Kian. Look at why we build VibeFlow. Introduction. When musicians practice today, they usually have to switch backward and forward between many different apps. They use YouTube for music, shop website for shop, and PDF app for notes. This is messy and distraction. VibeFlow solves this problem. It puts everything in one screen. While you play song, you can see the shop lyric and practice guide right in front of you at the same time. To power this app, our backend use Nest.js, GraphQL, and MongoDB. Those technologies handle user account, sell song information, and store lesson files safely. We also build the app using feature for structure. This means each feature like search the song player or log in is kept separately. This makes sure that the code is organized, easy to work on, and easy to expand later. Okay, let's move on. The purpose and objective. To guide our project, we focus on our four main goals. The first one is about learn while listening. User can play audio or video and study chop and lyric at the exact same screen without open another app. And the second one is about the fast function search. GraphQL power search return result as user type backed by our Nest.js API for reliable, consistent, and performance. And the third is about one material library. All PDFs, sheet music, and practice notes are stored together in one place so users don't lose files across different apps. And the last one is reliable and secure access. We use JWT login so users can safely log into those accounts, keep those data secure, and sell those custom shop layout. Next, my teammate will explain how we design the architecture of the app.
So yes, it is our app architecture. So the app architecture is our app follow the feature first architecture. So it means that every feature like the authentication, like the song karaoke is completely self-contained with its own model, service provider, and the screen. So this is made the code base easy to understand, easy to understand and manage, and also scale as we add more the feature. And for the state management, we use the report, so the data feed from our Nest.js backend through the GraphQL, and the core for the whole everything shared across the feature like the routing, theming, and the GraphQL client configuration. So here is our full user journey. So after the launching, the user can see the onboarder screen, and then they can register or log in and land on the home page, which is show the recommended song and the training content. From home, the user can search for a song, can browse their library, and also can manage a playlist or check their profile of friend. So when they search, they can tap any song. So when they tap on any song, they can see open the full playback control. One of our key UI feature is the sliding mini screen at the bottom. It persists on every screen, so the user never lost their music content while navigating. And from the player screen, user can tap on the karaoke button to enter the karaoke mode, which is the real synchronized lyric they can sing. And to summarize for our design decision, we choose the feature first architecture for the clean code separation. The report manage all the UI state reactively across the app, and authentication use the JWT token. And the audio playback is run on the Just Audio and the YouTube player Flutter. And the navigation is handled by the Go router and the authentication guard. So yeah. The global audio player is managed by a single report provider, so the music is never stopped when navigating between screens. So this is our design.
Hello teacher, my name is Davin. For my code implementation section, I will be presenting the three challenging parts that I'm working on in our music app. So as you can see in the slide, the first challenge is global audio player. This first building a global audio player that support both normal audio file and YouTube song. These two sources use different callback engine, but the user should experience them as one player with the same queue, loop mode, current song, and playback control. The difficult problem happens when the song finishes. The completion even could fire repeatedly, and multiple auto advance calls could run at the same time. This sometimes causes the player to skip more than one song or continue triggering at the end of the queue. To solve this, I first reset the global player state before stopping the audio or YouTube controller. This makes the current song null, so the completion listener stop firing again. I use the is transitioning flag. When an automatic transition is already running, another call is blocked. As a result, the player advance only one song at a time, support both audio and YouTube, respect loop mode, and stop safely after the final song. Okay, so move to the next slide. I cover about authenticate gradual request with secure token injection. Many features such as profile, relationship, playlist, and like song require a JWT access token. It would be unsafe and repetitive for every screen or service to read and attach the token manually. I solved this by creating the reusable authenticate gradual link. When authentication is required, Outlink read the access token from Flutter secure storage. On platform where the secure storage plug is unavailable, the code catch missing plugin exception and fall back to set preference. The method also check whether the token is null or empty. When a valid token exists, it returns it using the bearer format and combine the authentication link with the HTTP link. The result is that Protect service only requests an authenticate gradual client. The token is that attached automatically without exposing storage logic inside the user interface or individual feature service. Okay, so move on to the last slide of my part, follow state synchronization. The third challenge was keeping all relationship information synchronization after following or unfollowing another user. One mutation can affect several parts of the application at the same time. It changes the relationship status, follow count, following count, follower list, and following list. Without synchronization, one screen could show following, while another screen still display the old count. I used a report state notifier with async YU to manage this action. Before calling the service, the state became async loading. After success, it became async data, and error are stored using async error. When the mutation success, the code invalidate for a related provider. Report then automatically reflects the latest information from the backend. The result is that the bottom account relationship status and the user list all update consistently after the operation. This is server confirmed synchronization rather than an optimization local update. Together, this implementation show how the app handle synchronization, playback, secure API, authentication, and consistent state update across multiple screens. These were important for making the application reliable and connect to the real backend data.
So to wrap this up, we built this application called Whiteflow to be able to help individuals with their song management. What they can do is they can sing karaoke in it with lyrics in it, and they also can access to reference materials all in one place. And lastly, if they are the owner of a certain song, they can edit the lyrics and chords by themselves. They can play around in the add lyrics copy of the drag and drop or something like that. And then the tools that we use in this application, for the front end, we use Flutter, and for the back end, we use Nest.js and MongoDB with the integration of GraphQL. And in the future, we want to have a synchronization across devices and also smarter auto call detection. And lastly, we hope that our website or application can lead to deployment into App Store for iOS or Play Store for Android.